Welcome back to my class on our YouTube channel. We are in second order derivative for class 12 BUC second year mathematics. Topic is second order derivatives, exercise 5.7. We have already seen 12 questions. 12 questions from this exercise have been taught or completed in previous videos, right? Now, this time question number 13. Question number 13 is, if y is equal to 3 cos of log x plus 4 sin of log x, then show that x square y2 plus x y1 plus y is equal to 0. This is the given equation, given function. We have to get this equation, second order derivative. How do we know it's a second order derivative? It's y2 here. We have to differentiate twice, because we have to get y2, y1 as well as y2. y2 is second order derivative, right? So the given equation is y is equal to 3 cos of log x plus 4 sin of log x. This is the question. Now differentiate with respect to x. Differentiate with respect to x. If we differentiate with respect to x, then we get y1. Differentiation of y is y1, or you can write y dash, or you can write dy by dx, y1. Differentiate this. 3 is constant. You can keep as it is. 3 is constant. Cos of log x, it is in the form of cos x. Here in place of x we have log x. Cos x. Differentiation of cos x is minus sin x. But in place of x we have log x. So we have to differentiate log x also. We cannot just differentiate cos and leave it. We have to differentiate log x as well. So that will be 1 by x. Differentiation of log x is 1 by x. Differentiation of cos is minus sin, and differentiation of log is 1 by x. Here with cos we have angle log x. So here with sin also we are writing angle log x. If it was cos x only, then we will write minus sin x. But here we have cos of log x, therefore we are writing minus sin of log x, right? Plus, and differentiation of log x is also done. This one, 4 constant as it is. We know that with function, with x, if you have a constant number, keep it as it is. Don't differentiate it, right? Then differentiation of sin of log x, it is same as sin x. This is all x, sin x. Sin x differentiation is cos x. Right? Differentiation of sin is cos. Differentiation of cos is minus sin, and differentiation of sin is cos. So differentiation of cos sin of log x is cos of log x into differentiation of sin is over. We have to differentiate this also. It's a composite function. It's chain rule. We have to differentiate log x also in product, right? Into differentiation of log x is 1 by x. Now in these two terms, this is one term plus this is another term. In these two terms, we can take x as LCM. So it becomes y1 is equal to x is LCM. If we take x LCM, here what is left? Minus 3 sin of log x is left. This minus 3 sin of log x plus here also x get cancelled because we are taking LCM. It becomes 4 cos of log x. Right? Now take this x here. Transfer this x to LHS, it will multiply with y1, right? So it becomes xy1 is equal to, this x is taken here, xy1 is equal to minus 3 sin of log x plus 4 cos of log x. We got this. Now differentiate this equation once again, because we have to get y2. Differentiate again. Again differentiate with respect to x. Again differentiate with respect to x. Here we have two different functions, x and y, and they are in product. Therefore we have to apply product rule. Do you remember product rule? UV rule. UV. Differentiation of u into v is u as it is. U as it is. Differentiation of v plus v as it is. Differentiation of u. This is UV rule, product rule. When two functions are in product, you have to apply this rule. First function as it is, x as it is. Differentiation of y1 will be y2 plus second function y1 as it is. Differentiation of first function as it is. Differentiation of second plus second function as it is. Differentiation of first. Differentiation of x is 1 is equal to this derivative is over. Now differentiate this minus 3 constant as it is. Differentiation of sine of log x. Sine of log x is cos of log x into log x ka 1 by x plus 4 constant as it is. Differentiation of cos of log x will be minus sine of log x into 1 by x. This is second order derivative. We differentiate it again, right? Now keep it as it is. xy2 plus y1 as it is equal to, take LCM again here. We can again take LCM. X is LCM here. By x, x is LCM. So what will be left here? Minus 3 cos of log x plus into minus will become, plus into minus will become minus 4 sine of log x. Right? Now, what can we do here? Take this x here again. When we take this x here, it will multiply with this all. So it will become x into xy2 plus y1. This x is multiplied to this all is equal to, we can take minus sign common here. Take minus common. So it becomes 3 cos of log x plus, because minus is taken common, so minus will become plus. This minus is minus, both have minus sign, so we are taking minus common. So when we take minus common, negative becomes positive, positive becomes negative. So this minus will become plus and this minus will also become plus. So it becomes 4 sine of log x. Now multiply this, x into x, x square y2 plus x into y1, xy1 is equal to minus, if you observe carefully, this is the given equation. See here, 3 cos of log x plus 4 sine of log x, and this is equal to y. This is y. This is y is equal to y. So we can replace this all by y because this is equal to y is given in question, right? Now take this minus y here. It becomes x square y2 plus xy1. Take this minus y here. It becomes plus y is equal to 0. This is the required answer. We got the same answer as given. X square y2 plus xy1 plus y is equal to 0. Let's try next question. Next question, students. Next question is question number 14 in the same exercise 5.7. Question number 14 is, if y is equal to a into e to the power of mx plus b into e to the power of nx, then show that d square y by dx square minus m plus n into dy by dx plus mny is equal to 0. This we have to prove. Here a, b and m and n are constants. A, b, m, n are constants. Right? Now, to solve this question, we cannot do it as we did in previous questions. We just went down differentiating. We differentiated the given equation once, then twice, and we did some calculations, some mathematics, and we got the answer. Right? We cannot do it here. To solve this question, we have to do like this. See, given question is y is equal to, given equation is y is equal to a into e to the power of mx plus b into e to the power of nx. Right, now let's get dy by dx and d square y by dx square and see what happens. Dy by dx will be differentiate with respect to x. Right here, differentiate with respect to x. It's better, right? Now a is constant, keep it as it is. Differentiation of e to the power of mx, it is same as e to the power of x, right? But in place of x we have mx. Differentiation of e to the power of x is e to the power of x only. Differentiation of e to the power of x is e to the power of x same. But whatever is in the power, we must differentiate that also. But we don't do it here because it is only x. When it is only x, if you differentiate, it will be 1 and that makes no difference. That's why we do not write it. Right? Now, but here, it's not just e to the power of x, it is e to the power of m into x. So we have to differentiate this part also. We must differentiate the power as well. That makes a difference. If it was x, it becomes 1, it makes no difference. But mx makes difference. So differentiation of e to the power of mx is e to the power of mx only. E to the power of mx only, right? Into, we must differentiate mx also. Differentiate mx also. What is the differentiation of mx? M constant as it is, differentiation of x is 1. So that will be m only, right? Plus b constant as it is, differentiation of e to the power of nx, that will be e to the power of nx, e to the power of x का differentiation e to the power of x ही है, e to the power of nx हो गया into x होता तो हम छोड़ देते थे, लेकिन nx है इसीलिए इसका भी differentiation करना nx का, n constant as it is, x का differentiation हो गया 1. So we got the first order derivative, that is first order derivative is m a e to the power of mx plus n b e to the power of nx, n b e to the power of nx. This is first order derivative. Let's differentiate again. D square y by dx square. D square y by dx square will be equal to m a constant as it is. E to the power of mx differentiation is e to the power of mx into m constant as it is. Differentiation of x is 1 plus nb constant as it is. E to the power of nx differentiation is e to the power of nx into differentiation of nx will be n into 1. So that becomes d square y by dx square is equal to, this becomes m square a e to the power of mx plus this becomes n into n square b e to the power of nx. We got second order derivative, right? Now we are not getting this here. We can get, if we do something, easier way is take this equation. We have to prove that this LHS all d square y by dx square minus n plus n into dy by dx plus mny is equal to 0. This is equal to 0. This we have to prove, right? For that, take LHS. Take this LHS. What is LHS? In given what we have to prove, LHS is d square y by dx square plus minus m plus n into dy by dx plus mny. This is LHS. This is LHS. Now, if we substitute d square y by dx value here and then dy by dx value here and simplify, we must get 0. Right? This is LHS. We have to get RHS as 0. So here I have written LHS. Let's substitute the values. D square y by dx square. What is d square y by dx square? We got it here. That is m square a e to the power of mx plus n square b e to the power of nx. This is the value of d square y by dx square. I wrote it. We got here. We have done it. We found the first order derivative, then we found second order derivative, right? So we are substituting the values. D square y by dx square value is substituted already. Then minus m plus n as it is. M plus n as it is. dy by dx. What is the value of dy by dx? We found it here. dy by dx is here. dy by dx is m a e to the power of mx plus n b e to the power of nx. So write it. M a e to the power of mx plus n b e to the power of nx. This is dy by dx, right? Plus y, right? m n y. What is the value of y? Y is given in the question. Y is a e to the power of mx plus b e to the power of nx, right? I write it. A e to the power of mx plus b e to the power of nx. This is y. M n y. Right? M n y. We wrote it. Now, on simplifying this, we must get 0. Let's see if we can it or not. That will be equal to m square a e to the power of mx as it is plus this n square b e to the power of nx as it is. Now multiply this. If we multiply this, this will multiply to this will multiply to this, then this multiply to this, and this will multiply to this. Right? We are multiplying a binomial by binomial. So that becomes minus into plus is minus, m into m is m square a e to the power of mx. Then minus into plus is minus, m into this, that becomes m n b e to the power of nx. Then minus into plus minus, n into this, that becomes n into this, m n this mn, right? A e to the power of mx. Then multiply this by this. That becomes minus into plus is minus again. We have a minus here. That's why this minus will multiply to all. So here we have all positive. So minus into plus all will become minus. So all terms becoming negative, right? Minus into plus minus, minus into plus minus, minus into plus minus, minus into plus minus. All will get minus, right? Now this into this, n into this. So that n into n will become n square. Then here we have b e to the power of nx here. Now this one we have to multiply this also. mn into this and mn into this, right? So that becomes plus into plus is plus mn a e to the power of mx plus into plus plus mn b e to the power of nx, right? We got this. We multiplied. So this is b e to the power of nx, right? We have this. Now, see, we have a positive m square a e to the power of mx here. We have a negative m square a e to the power of mx here. They get cancelled. Then we have here n square b e to the power of nx plus, and this is minus n square. These two terms, they are same but having different sign. So this n square b e to the power of nx plus and this minus will get cancelled. Then we have here minus mn b e to the power of nx. We have here plus mn b e to the power of nx. These two terms are also same but having different sign. They will also get cancelled. Then we have minus mn a em to the power of x plus mn a e m to the power of x, right? We have mn a e to the power of mx plus mn a e to the power of mx. One positive, one negative get cancelled. So if you observe carefully, all terms have got cancelled. All terms got cancelled. So what is left? Nothing. That is 0. This is what we had to prove. We got 0. In this LHS, we substituted the values. We got RHS 0. Like this we have to prove. So it's different from earlier questions, right? Practice this question. We have this kind of question. Next question also is this type. We'll solve it in next video. Thank you for watching.